The height h of a firework can reach is related to the mass m of fuel it carries as shown by this formula, and find the mass of the fuel required to achieve the maximum height and state what the maximum height is. So for maximum height, so if we had so cubic, so somewhat like this, so say the maximum height is reached here, right? So this is the maximum height it can reach, and maybe after that it burns out, so it can't go up any further. So the maximum height is this, and at maximum height, so this is stationary point, so therefore you would have dh out of dm equals 0 at maximum height. So what happens is we need to differentiate this term. So dh out of dm is equal to 2m out of 10 minus 3m square out of 800. So I would get dh out of dm equals m out of 5 minus 5, 3m square out of 800, and that equals 0, and that implies if you get m out, 1 out of 5 minus 3m out of 800 equals 0. So m is not equal 0, and therefore 1 out of 5 minus 3m out of 800 is 0. And from here, we would get 1 out of 5 equals 3m out of 800, and then we can cancel it out. 5 times 1 is 5, 6, 160, so we get therefore m is 160 divided by 3, and that equals 53.3 grams. So that is the mass of the fuel. Okay, so then we need to find the maximum height. So to get that, we will need to put in these, substitute m with 53.3, put in the value of m. So we can say that h would equal 160, I keep it 160 out of 3 square times 1 out of 10 minus 160 out of 3 cube times 1 out of 800. So that would be 160 so that is 284.4 minus 27. So I get 189.6. .8 meter.